Let's look at this multiplication problem. Again, it's a multiplication problem in which we have three factors, three fractions. And interestingly enough, our last fraction, both the numerator and denominator, are decimal numbers. Again, it's oftentimes helpful to get rid of those decimal numbers to make our multiplication easier. And the technique we use is to multiply the numerator and denominator by the same quantity, a quantity that will move the decimal point so that we have no longer any digits to the right of the decimal point. Well, if I look at this quantity, 36 hundredths, that hundredths tells me what I need to multiply by in order to clear the decimal. I need to multiply by 100 because I need to move the decimal point 2 places to the right so that I no longer have any digits to the right of the decimal point. That takes a multiplication by 100. Remember, when you multiply by numbers like 10, 100, 1,000, it moves the decimal point the same number of places to the right as the number of zeros in the number. So if you multiply by 100, it would move the decimal point of the other factor 2 places to the right, which is what I want to do. I want to get rid of any digits to the right of the decimal point in that number. But in order to keep the value of my fraction the same, I have to multiply the numerator by the same quantity. So if I multiply the numerator and denominator both by 100, I'm not going to change the value of the fraction, I'm just going to change its appearance, and that will make it easier to do the reducing that I want to do in this overall multiplication problem. So now, 1/10 times 100 gives me 10, and 36 hundredths times 100 gives me 36. And now I have a much easier problem to work with when it comes to reducing before I finish my multiplication. Well, one thing I should notice right away, 5 and 25 both are divisible by 5. 5 divides into 5 divides into 5 one time. 5 divides into 25 5 times. 5 will also go into 10. So 5 divides into 5 one time. 5 divides into 10 2 times. How about 60 and 36? There are a number of factors they share in common. We should recognize right away that they're both divisible by 6, but they're also both divisible by 12. 12 will go into 36 3 times. 12 goes into 60 5 times. And then lastly, the 2 and the 4 are both divisible by 2. 2 divides into 2 one time, 2 divides into 4 2 times. And look at all that reducing I've been able to do, which is going to make my multiplication much easier. 1 times 5 is 5, 5 times 1 is 5. 2 times 1 is 2, 2 times 3 is 6. So the value of that product is 5/6 as a fraction. And if I wanted to convert that to its decimal equivalence, I would perform a division. I would divide the denominator into the numerator. That's how we always convert fractions to decimal equivalents. 6 won't go into 5. 6 goes into 58 times. 8 times 6 is 48. Remainder of 2. Bring down the 0. 6 goes into 20 3 times. 3 times 6 is 18, with a remainder of 2. Oh, and do we begin to see a pattern here? 6 goes into 20 3 times, and so on. So aren't we going to have a repeating value of 3 there? So if we wanted to express 5/6 as a decimal equivalent, let's say rounded to the nearest hundredth. Rounded to the nearest hundredth, so I'd have to look at the thousandths place. That's a 3, so it won't change this 3. So to the nearest hundredth, 5/6 is equal to 83 hundredths. If I wanted to round to the nearest tenth, then I would look at this 3 in the hundredths place, which means I wouldn't change the 8, and my value to the nearest tenth would be 8/10. So we have to know the place to which we are to round when we are getting the decimal equivalent of a fraction.